Alright, today I'm going to show you how to rationalize denominators, and rationalizing the denominator is just a process of getting a radical out of a denominator. You can see here that these are equivalent, but they are written just a little bit differently, and there are three reasons that I could think of why we do this. One of the reasons is that it makes things a lot easier to check. If you're looking in the back of the book, if we have a systematic way of writing these, it makes it a lot easier to check, and also when you're grading quizzes or tests, it makes things much easier. If you're in trigonometry and you're using the unit circle, the ordered pairs will always be written with rationalized denominators. And lastly, before calculators, back in the day, it was much easier to do this calculation by hand. Having a denominator that was irrational was very difficult to do, so they rationalized the denominators to make things easier. Alright, before we rationalize any denominators, there's some basic multiplication that you need to have a firm grasp on to make things much easier. The first one here, we have the square root of 5 times the square root of 5, which is the square root of 5 squared, which is just 5. Or you could write it like this, 5 times 5, which is the square root of 25, which once again is just 5. The square root of m times the square root of m is the square root of m squared, which is just m. If we're distributing, if we have two binomials that they're the same but they differ by sign, I'll show you what happens. We get x squared minus a 6x plus 6x and minus a 36. These middle terms are going to cancel out, so we're left with just x squared minus 36. Let's look at this example at the bottom left. We get x squared, a positive 3x and a negative 3x are going to cancel out, and I'm left with a negative 9. Here we get x squared minus xy plus xy. Those are going to cancel out. And a positive times a negative is a negative, and y times y is y squared. So we're left with x squared minus y squared. And the last example, x times x is x squared. That's a minus x root 7. It's a plus x root 7. Those are going to cancel out. And a positive times a negative is a negative. The square root of 7 times the square root of 7 is the square root of 49, which is just 7. So we're left with x squared minus 7. Alright, let's take a look at three examples. The first one here is we have 2 divided by the square root of 5, and we look over here. If I have the square root of just one number in my denominator, I'm going to multiply by the square root of that number divided by the square root of that number. So I'm going to multiply by the square root of 5 divided by the square root of 5. And keep in mind, this is just 1. Anything divided by itself is just 1. And if we multiply something by 1, we don't change it. We can change how it looks, but it's not going to change its value. So we have 2 root 5, and the square root of 5 times the square root of 5 is just 5. And that can't be reduced, so we're done. Here we have in our denominator a 3 plus root 6. If I have something plus something, I'm going to multiply by its conjugate. That's something minus something. Alright, those are known as conjugates. So I'm going to multiply by 3 minus root 6 over 3 minus root 6. And we're left with 2 times 3 is 6 minus 2 root 6 divided by 3 times 3 is 9, and 3 times negative root 6 and 3 times positive root 6, those are going to cancel out, and a positive times a negative is a negative. The square root of 6 times the square root of 6 is just 6. So this is 6 minus 2 root 6 over 3. And we're done with that one. Lastly, we have radicals in both the numerator and the denominator, but the square root of 2 up top doesn't matter. We don't care if they're in the top. We were worried about them if they're in the bottom, so that square root of 2 can stay there, and we have a subtraction, so I'm going to multiply by the conjugate, 7 plus the square root of 3, divided by 7 plus the square root of 3. And keep in mind, 7 plus the square root of 3 over 7 plus the square root of 3 is just 1. So we get 1 times 7, which is just 7, and 1 times the square root of 3, which is the square root of 3. Square root of 2 times 7 is 7 root 2. And the square root of 2 times the square root of 3 is the square root of 6. On the bottom, we get 49. And these middle terms are going to cancel out. And a negative times a positive is a negative. The square root of 3 times the square root of 3 is 3. Right, we can rewrite this as 7 plus root 3 plus 7 root 2 plus root 6 over 46.